Welcome everybody. Today we want to solve some of the questions from past papers in chemistry. I hope you enjoy it. After you've finished your study, it's time to test what you studied. And here we have the peripheral question. The question says, for each of the following unfamiliar elements, predict one of the physical and chemical property. The keyword of solving this type of a question is determining the position of this element in the periodic table. As we see, this element locates in group number 1. So you have to just come over what are the physical and chemical properties of group number 1. You should be able to distinguish between physical and chemical properties in terms of not to lose the marks. Some of the students reverse the physical and chemical properties and they just got nothing. So here, as we know that most of, let's say, the general physical properties of a group number 1 elements, they have low melting and boiling points, they have low density. The mark scheme answered the physical properties. It's okay and it's right to write it has low density or light or low melting point or good conductor. But good conductor of heat and electricity and shiny are the general properties of metals. So it's okay in case you're just making a comparison between chemical and physical properties. But it's not correct to say it's good conductor when you want to make a comparison between group 1 elements and the transition elements, because transition elements in group number 1 are metal, so they are both of them conduct electricity, they conduct heat, they are shiny, and like etc. Let's start with chemical properties of a group number 1 elements. And cesium is a very reactive element, so their chemical properties are considered that have very reactive elements. They react with water, they react with halogens forming halide, and they just produce alkaline solution when they react with water, and they have a fixed oxidation number. So these are the main chemical properties of group number 1 elements. And now it's time to go to branch B, vanadium V. The first step, as we told you before, is determining the location of vanadium element. As we see, vanadium element locates in the block of transition elements, so we just want to come over what are the physical and chemical properties of transition elements. And again, never reverse the physical and chemical properties, and you have to be able to distinguish between them well. And now let's talk about what are the physical properties of vanadium. As we see, vanadium locates in the transition elements block, so it has high density, or let's say you can say it's dense. It has high melting and boiling point, and this is due to the strong metallic bonding. And you can mention the physical properties of metals in general because you're making comparison between physical and chemical properties. So it's okay to write it's a ductile, it's malleable, it's strong, or it's a lustrous or shiny solid. So these things you should put in your mind. A lot of students confuse between physical and chemical properties of transition elements, but you should put in your mind chemical properties are so clear. Chemical properties of transition elements such as more than one oxidation number, or let's say form colored compound, they can form complex ions, they behave as a catalyst, and they're less reactive than group number 1. And now let's jump to electrolysis by hitting this beautiful question. It says, electricity was passed through molten lead bromide using the apparatus shown. The formation of a brown gas was observed at the positive electrode. A. Give one other expected observation. As we see in the speaker, lead bromide is a liquid state and there is no aqueous solution. So lead ions will attract to the cathode, bromide ions will attract to the anode. Okay, what happened after that? The current passes through the circuit, turning the light on. At the cathode, lead ions attracted too, making them reduced. As a result of reduction of lead, it turns to atoms, forming silver shiny element or metal. Maybe it's in liquid state or solid state. It depends on the temperature of the cell. So the answer will be as we see. And now let's hit the second question, which is Name a metal that could be used for electrodes. So we have two possible inert electrodes, which are platinum and carbon, but the question determines the non-metal one. So the non-metal will be carbon or graphite. And let's go to II. Suggest why iron is not used for the electrodes, because we are using inert electrode. Iron is not inert, so the answer will be. And now let's go to CI. Name the brown gas formed. The oxidation process of the bromide ions leads to produce bromine. So the product at the anode will be bromine gas. So you have to write bromine. Don't write the formula, write the name. CII. Suggest the result of testing this gas with a damp blue litmus paper. You have to put in your mind, bromine is a halogen, same as the chlorine. So their effect is the same in the litmus paper. Both the bromine and chlorine bleach the litmus paper. D. Name the product formed at the negative electrode. As a result of attracting the lead ions into the cathode, reduction process takes place, so the product will be lead. Again, when we ask you to name the product, don't write the symbols or the formula, you have to write the name itself. So the answer will be lead. And now let's go to another question, which is about electrolysis of copper sulfate solution. As we see, this is a normal cell that consists of aqueous copper sulfate solution, and it's connected to carbon electrodes and the battery. So let's start with question I. It says, draw an arrow on the diagram to show the direction of movement of electrons in the wire. Label the arrow A. As we told you before, the electrons in the wires start flowing from the negative terminal to the cathode. So the direction of electrons in the wire will be anti-clockwise. AII. Draw an arrow on the diagram to show the direction of movement of positive ions in the copper sulfate solution. Label the arrow B. The positive ions in copper sulfate is copper plus 2, which are moving towards the cathode, which is the negatively charged electrode. And now let's jump to B. Oxygen was formed at the anode and copper was formed at the cathode. The ionic half equation for the formation of oxygen is shown. Explain why this reaction is oxidation. Surely we have loss of electrons, okay? Or you can say there is increase in the oxidation number. Oxidation number of oxygen in OH is equal to -2 and then in turn to 0. So there is increase in the oxidation number. Increasing the oxidation number is considered as oxidation process. B, II, write the ionic half equation for the formation of copper at the cathode. Surely, at the cathode, the reduction process takes place, so copper ions gain 2 electrons, forming copper atoms. So, as we notice that we have 2 marks on this question. So, when you ask yourself, why do I have 2 marks? Because you have to write balanced equation and you have to determine the position of ions in both both sides of the equation. Sometimes people reflect the ions and they put them on the right side instead of the left one, so you have to put this in your mind. Branch C, the electrolysis was repeated using copper electrodes in place of carbon electrodes. State and explain what happens to the masses of anode and cathode during the electrolysis. As a result of the oxidation process of the anode, the mass of anode decreases. You can explain this decrease by an equation. The same for cathode. The mass increases, and this is as a result of the copper layer deposited on the cathode. And so you can explain this by half reduction equation. You have to be aware of these type of questions because it has 4 marks, which means that you have to mention 4 points or 4 things. So stay safe. How to electroplate a key. A student carried out an investigation to coat a copper key with nickel. He followed these instructions. He rubbed the copper key with sandpaper, and this is for cleaning issues. And then he set up the circuit as shown, switched on the circuit for 10 minutes, and then he removed the key, washed, and dry. So what are the following questions? The first question, A. Name the process used to coat the copper key with nickel. Of course, it's electroplating. Why was the key wrapped with sandpaper? Actually, this question is for cleaning issues. If you want to clean the surface of the metal that you want to electroplate, because all of metals react with atmosphere, forming a layer above them. C. Name a possible electrolyte that could be used. For sure, we have two main conditions for this electrolyte. This electrolyte should be an aqueous solution and should be soluble in this aqueous solution. So any solution that contains nickel salts or nickel ions in presence of water is considered as good electrolyte for electroplating. Okay guys, we're done with this video. I hope you enjoy it. If you have any questions, you can ask me in the comments below. Have a nice day.